this episode, we take a look at a clinical trial published in Medicines and Science in Sports and Exercise. This study examined how different intensities of aerobic training affects abdominal fat, especially visceral fat, which is closely linked to metabolic risk factors. All participants had metabolic syndrome and the training programs were matched in energy expenditure. What changed and what didn't is what we'll unpack now. Let's get into it. But first, let's take a look at MET-S. Metabolic syndrome, that's the name for a combination of things like high blood pressure, low HDL cholesterol, insulin resistant, and especially too much abdominal fat. Among the different types of body fat, visceral fat, the one that sits deep around your organs, is considered a key risk factor for cardiovascular and metabolic diseases. This study explored a specific question. If two training programs burn the same number of calories but differ in intensity, what is the different outcome on abdominal fat? But before we talk results, let's take a look on the design of the study. The trial involved 27 women, all middle-aged, obese, and diagnosed with metabolic syndrome. They were split in 3 different groups. First, a control group, no changes and physical activity. Second, a low-intensity group, training below lactate threshold, 5 times a week. And third, a high-intensity group, training above lactate threshold on 3 days and below on 2. Here's the key. Each group that trained burned about 400 calories per session. So the researchers could isolate intensity as the main variable. To track body composition, the team used CT scans at L4, L5 level to measure both visceral and subcutaneous abdominal fat. They also used the BOD pod to measure body fat percentage and a graded treadmill test to determine aerobic capacity, or VO₂peak. Training zones were based on each person's lactate threshold, measured through repeated blood samples during exercise. Let's talk results now. After 16 weeks, only the high-intensity group showed statistically significant reductions in total abdominal fat, subcutaneous fat, and visceral fat. On average, they lost about 24 square centimeters of visceral fat, compared to 7 square centimeters in the low-intensity group. Weight, BMI, and fat mass also decreased in the high intensity, but not in the control or light intensity group. Looking at blood markers and blood pressure, systolic blood pressure decreased in the low intensity group. Waist circumference went down in the high intensity group. No significant changes were seen in fasting glucose, triglycerides, and HDL cholesterol. The study wasn't designed to detect small effects in these secondary outcomes, so conclusions here remain limited. Aerobic capacity, measured by VO₂peak, improved in both training groups, but the increase was larger in the high-intensity group. Peak treadmill speed followed the same pattern. Lactate threshold, VO2, however, didn't change in any group. But how to interpret these outcomes? Based on the data, training intensity appears to be a relevant factor for changes in body composition, especially reductions in abdominal fat. Only high-intensity training led to statistically significant reductions in visceral fat, BMI, and fat mass compared to baseline. However, not all between-group comparisons reached statistical significance, and small sample size limits broader interpretations. The authors highlight several limitations. Sample size, no control for dietary intake, visceral fat measured by single-slice CT, not multi-slice. These factors may have influenced the precision and generalizability of the results. In summary, this study found that aerobic training above lactate threshold led to measurable reductions in visceral fat and improvements in body composition in women with metabolic syndrome. All groups had equal energy expenditure, highlighting the role of intensity as a differentiating factor. You can find the original paper in the description. Also, the citations and DOI are linked in the description as well.